So my name is Lingzhou. I'm an associate professor in the Department of Statistics at Penn State. So I'm also a member of the 2021 class of the COPSS Leadership Academy. So as a little background, so COPSS is made of 5 statistical societies. So ASA, INA, WINA, IMS, and SSC. So with many friends of societies across the world. And NISS is a national institute that aims to promote high-impact cross-disciplinary and cross-sector research involving the statistical data sciences. So we organize these COPSS-NISS leadership webinars. So they provide opportunity for all of us to meet leaders through the discipline, throughout the discipline, and invite them to tell their leadership story and share their insights. So this is also an opportunity to celebrate statisticians and data scientists who have achieved great things, who have inspired others in many different ways. So today, we are very happy to have Susan and Trevor here. So today's topic is the leadership in statistical research. So we are fortunate today to have 2 of our own with us today here, and Professor Susan Murphy and Professor Trevor Hastie. So who have risen to 2 of the greatest statistical and data science researchers in the world nowadays, and who have had enormous impacts in many research fields. So we are so pleased to have them here with us. So today, the structure is as follows. So I will first introduce Professor Susan Murphy, and then she will have about 10 minutes to talk about her story and also share her advice. And then I will introduce Professor Trevor Hastie, and then he will share his story. And then we're going to have several questions for both of them. And then in the last part of this webinar, I'm going to open it to the public audience so that we can have a public Q&A. So this is today's structure. So first we're going to have I'm going to introduce Susan. So Trevor, you can turn your camera off. So and Professor Susan Murphy, so is a distinguished professor of statistics and computer science at Harvard University. So her research focuses on improving sequential individualized decision-making in health. She developed the micro-randomized trial for use in constructing digital health interventions, so which is in use across a wide range of health-related areas. Before joining Harvard, so she was a faculty member at Penn State, and then a faculty member at University of Michigan. So she has many honors and awards. So she is a member of the National Academy of Sciences, and also a member of the National Academy of Medicine. And in 2013, she was awarded a MacArthur Fellowship. She is also a past president of IMS, and also the past president of the Bernoulli Society. She's also former editor of the Annals of Statistics. So if I could keep going, we're gonna be here all day. So yeah, so let's welcome Susan. Yeah.
Thanks so much. Thanks for the invitation. And I can't tell you, you guys, how exciting it is to be here today paired with Trevor. Like when I was first going out, I'd meet Trevor, and Trevor was friendly to everybody and always being so just so personable and reachable by everyone. It was just wonderful. So it's a great honor to be here today with Trevor. So I was going to go through some, I don't know, these are just aspects of the experience I've had and a few little horror stories. So you can see that we all have our horror stories. All of us have a collection of horror stories. So I just, the first thing I want to say is, the first message I want to communicate is that to be prepared for opportunities that you get. And often, like I came out of Southern Louisiana, the countryside in Louisiana, and then I went to Chapel Hill for graduate school. And of course, as someone who was educated in the American system, my mathematics background was nowhere near as strong as it needed to be. And so as a result, when I got opportunities in Chapel Hill at UNC, often they might not have been the same kind of opportunities that some of the other people were getting. But the lesson I learned is you take those opportunities, you take the ones you get and you make the most of them. And you don't think, well, I wish I had gotten an opportunity like the guy sitting next to me. Also, at Chapel Hill, I was very fortunate. Russ Ledbetter was very kind to me and actually added classes in point processes and random measures because of my question. So I really appreciate this influence of someone while I was a grad student. It made a big difference to me. Another message I wanted to give, a second message, is we all want to take chances, but sometimes they don't go so well, or they're a little too risky. And I did that with my PhD thesis. I fell in love with martingale theory, and I decided that I was going to work in martingale theory and survival analysis no matter what anyone said. And so I didn't work on a topic that any of the faculty were really interested in. And and this was extremely dangerous, and I didn't understand that at the time. I was fortunate. Penn State offered me a job, but I was probably very lucky I got that job offer. Then another time I took a chance and it paid off handsomely. I was visiting Richard Gill, and I had solved a problem that he'd been trying to solve. And I showed him how I solved the problem. And I asked him, will you write me a letter so I can go to the Misery in Berkeley? And it panned out. He said, yes, I got lucky. So sometimes taking chances can pay off. Sometimes it's very risky and you suffer, but you got to decide what level of risk you want to take. Another thing I learned was just to keep going on, to keep moving forward. So my first NSF grant, I submitted it. This was when I was first at Penn State. I submitted this grant, and I submitted another one at the same time, but this one in particular, this is the one that was the more theoretical. I was quite proud of it. And one of the reviewers came back and said they were surprised that the author of this application, i.e. me, was even able to get a PhD because the problems they were attempting to solve were just not solvable. But I just continued, it was very upsetting. I was very stressful, like I don't know how many weeks, but I just continued on. And I recommend that one try. Anyone listening who's younger, who has a similar negative experience when you get your reviews from your NSF grant application, you just continue on. Another time, though, I got a bad rejection. I was working on a paper with Michael Akritis at Penn State. The paper got rejected from a journal. I can't even remember the journal. It wasn't, but it got immediately rejected. And Michael looked at the rejection. This was a great lesson for me. He looked at the rejection. He said, this rejection it doesn't make sense. And instead of revising the paper, we went around and resubmitted it to JASA, and it got accepted immediately. So there's another lesson. I mean, sometimes you just you got to move on. You got rejected, or at least I felt like I was being rejected instead of my paper or my grant application. But moving on was the right path in the end. And so another thing that became really important for me was communication. I didn't really go to grad school with great communication skills or skills where I could communicate across disciplinary boundaries. And I have to thank multiple social scientists and behavioral scientists for really spending a lot of time trying to help me improve my communication skills. And I do believe that this is really important. And it's hard as a statistician to think that that's valuable, but it's played an enormous role in my life. So these individuals who really helped me, these were a behavioral scientist, Linda Collins, Steve Roundbush, who's education, and Yushia, who's in sociology. All of these individuals really helped me improve my ability to communicate. And it was worth it. It paid off big time, even though from a statistical, immediately it didn't seem like it was paying off, but long term it paid off big time. One of the things I learned from Steve Roundbush, this is the guy who was in education. He was an applied statistician in education, but mainly an educator, a researcher in education. He always counseled me, focus on the small steps. You have some larger goal, but you break it up into small steps, and you really focus on those small steps. And this made, I can even remember now him telling me this, and it made a big impression. And I really try and follow that even to today in my life, is really focusing on the small steps to achieve some task, to finish a paper, to finish a grant application, to finish some sort of big collaboration, and not think so much about the longer term goal that it makes me stress out or something. Focus on, just move forward, focus on moving forward. Another thing I learned was to try, and this, I didn't really learn this from someone else, but it became clearer and clearer to me that this was critical, and that was deciding where I wanted to try and pursue excellence. And of course, research, that was critical. We all share that. But another was I wanted to really pursue, to try as best I could to achieve a good reputation. So I made an enormous effort to complete very high quality reviews. At that time, I was reviewing mainly annals type papers. And when I was offered, got the chance to be a program secretary at IMS, I made an enormous effort to try and be really proactive and do the very best job. And this all paid off later, because when I was program secretary, Bernard Silverman was president. And then later on, when he was asked to edit the annals, he was told he would have a co-editor, and he asked who he would like as co-editor, and he asked me. So this striving for that excellence in terms of providing very high quality reviews, trying to do a really good job as a program secretary in service of our society, i.e. in this case, IMS, it really paid off for me. And of course, I appreciate the opportunity that Bernard provided to me as well. Oh, right. I got to tell you the story about improved communication, just so that y'all know how bad things were. So, as I said, I struggled a lot with communicating across disciplinary boundaries. In general, just communication with anyone. Pretty much all I wanted to do was be by myself and do math. And so when I first started working towards more interdisciplinary work, I got involved with this big consortium in conduct disorder. A lot of health scientists, behavioral scientists, and they had a retreat. And I went to the retreat, and they asked me at the retreat, it was in the morning, they asked me to have a conversation with them. And I don't know really what I said, but it's pretty clear my communication skills were not good, because they made me leave the room and I had to walk around the neighborhood the rest of the day. And to this day, I don't know what I did wrong, but that just gives you a feeling for how much effort I had to put into improving my communication. It's really paid off. Another thing I try to do is I'm still trying really hard, is to be open to criticism by colleagues, other statisticians, people in other fields. And to this day, I can also remember I went to Harvard to give a talk. At that time, I think I was at Michigan by then. And I gave a talk on sequential decision-making, and I had this meeting with Don Rubin. And Don Rubin was pretty critical of what I was doing. I was doing something, my talk was quite theoretical, and I had many decision points at which treatments could be randomized, and he just thought it was just unintelligible. And I took that to heart. I mean, it was upsetting, but I took it to heart. And I went back, and that's when I spent a good bit of time developing this experimental trial design for clinical decision making. It's called the sequential multiple assignment randomized trials, and that's how I got that MacArthur Award. So by listening to Ruben, his pretty critical, his criticism, that led me down a path which really helped me do better science, and it's great. And I want to continue to be open like that. The last thing I wanted to say is, and this is related to being open to criticism, is something that's really helped me is continually putting myself in a situation where I am not the expert, where I'm uncomfortable and I'm very, very confused. So I did this both at Penn State when I got involved with this consortium of health and behavioral scientists. And then when I went to Michigan, when I got involved with the Institute for Social Research, again, all of this at this time, this was all sequential decision-making, but nonetheless, I could follow these guys like Steve Roundbush and Ushia. They went between math and English very rapidly, and we'd have these communications, and I could keep up about 10 minutes, and then I was just lost. So it was great. It helped me really improve by putting myself in a situation where I was really uncomfortable. And I'm doing that now. Now my lab is inside the computer science department at Harvard. And for the most part, I'm pretty confused and I'm out of my element. But it's a little stressful, but I think it's very good for me. It makes me think, and I highly recommend this. It's a little stressful, like I said, but I highly recommend putting yourself in an uncomfortable setting so that you can expand your horizons. Okay, Lingzhou, that's all I had to say.
Yeah, thank you, Susan, for so many wonderful stories and experiences. So now you can take a short break. So we're gonna, switch to the Trevor. So let me introduce Trevor. So the Professor Trevor Hastie, so is a distinguished professor of mathematical sciences and statistics and biomedical data science at Stanford University. So he invented the principal curves and services and generalized additive models. He is also known for his research that contributed toward the understanding of machine learning techniques through a statistical lens, so including boosting support vector machine and random forest. So he also has many author of many important methods, so that he published 6 books and many popular software packages, which are being used by hundreds of thousands of researchers in the world. So before joining Stanford, he worked at ATT Bell Lab for 9 years. So he was also the chair of the Department of Statistics at Stanford for 3 years. So he's a member of the National Academy of Sciences. So he is also a foreign member of the Royal Netherlands Academy of Arts and Science. So he has many other honors and awards. So again, if I could keep going, we're going to be here all day. So let's skip those. So let's welcome Trevor to share his story and experience. Yeah.
Thank you very much, Lingzhou, and also Susan. Thank you for those lovely remarks. I've always thought you were a fantastic communicator, very fresh and always interesting to listen to. And by the way, you were the coolest visitor to Stanford some years back. Susan just reminded me that she showed up at to the seminars on rollerblades. So it's a real honor to be doing this alongside Susan Murphy. So Susan probably gave the right kind of talk. I didn't quite prepare to talk like that. I was going to just tell you what my path was. And I started off, I'm a South African, grew up in South Africa. I'm a joint citizen now. And once I got my bachelor's degree in South Africa, I majored in math and statistics, and I wanted to do something applied. So I joined the Medical Research Council in South Africa as a in the division of biostatistics. And this turned out to be a really good place for me. There were a lot of medical issues in South Africa to do with poorer communities, such as perinatal mortality and asthma, and GI issues, mining-related diseases, such as mesothelioma, and diet-related diseases, such as coronary heart disease. AIDS came later, but this was in the 70s. Back then, statistics was done using batch processed runs with packages like SPSS, BMDP, and SAS, and I became the local expert because I was also had a co-minor in computer science. And despite the fact that I did not understand all the output and did not have the knowledge to really understand the literature. So after working there for 3 years, that really prompted me to do a PhD. And I was lucky enough to spend close to a year in England at the London School of Hygiene and Tropical Medicine for 6 months, working with Professor Michael Healy as an assistant. I spent some time at the Johnson Space Center in Texas, and then at the Oxford Biomath Department as a research assistant to Professor Peter Armitage. And all these experiences convinced me that I needed to do a PhD. And so I got into the PhD program at Stanford in 1980, and my advisor was Werner Stutzler. But importantly, during that time, I became friends with Rob Tibshirani, who was just a year behind me. He was also a graduate student at the time. And we wrote a paper, our first paper together, Generalized Additive Models. And this, for one thing, it was published in Statistical Science a year or two later with discussion. But this was like a huge thing for me. And discovering Rob, who has been a great collaborator for the rest of my career and a perfect match, this was something that's clearly important, has been important in my career. If you can find 1 or 2 people that you work well with and collaborate with, it really makes a difference in your research journey. At the time, I also married Linda, who's my lifelong partner and support person and the love of my life. So after graduating from Stanford, I went back to South Africa for a year and worked back at the Medical Research Council, but things weren't good in South Africa in 1986. In fact, they were terrible politically with apartheid and so on. And I got an offer to work at AT&T Bell Laboratories, which I went there. And for someone like me who had a keen interest in computing, this was heaven. We had the best computing environment you could find at the time, with graphic terminals, and when you received an email, a little picture of the sender's face appeared. I mean, this was really ahead of the time, and I loved it. So during the time at Bell Labs, Rob Tibshirani used to be a frequent visitor, and we wrote our book on generalized additive models, which was published in 1990. And I should say that writing a book as a young researcher is quite a risk, because it takes a lot of time, and it could be a flop. In our case, it wasn't a flop, but that's a risk. So if it's a success, you reap dividends, but it's kind of risky. But if you really believe in the topic and the book, then I think that's something to do. I was also lucky at the time to work in the group with John Chambers, and we wrote a book on statistical models in S, which was the foundation for a lot of the modeling software that we use in R today. For example, we wrote the GLM and LM functions, the formula language, data frames, and so on. And so for me, that was a really nice opportunity. The other thing, now this is kind of off topic. We weren't too well off, and we bought an old house, a fixer-upper, as they say, had 2 children, and I had to learn through trial and error to fix houses. And I had good colleagues and good neighbors who knew how to do plumbing and electrical work. And so I learned that on the weekends and was able to work on my house. Now, the reason I say that is because this is to do with work and lifestyle balance. And on the weekends, I didn't do any research or anything. I just worked on projects on the home and was with the family. And having that division, that break, I think was really good for the mind. Now, I'd promised Linda that we'd be at Bell Labs for at most 4 years because the climate in New Jersey was a little harsh for us, especially having experienced California. And after 8 years, we moved back to California. I got a job at Stanford. We bought another fix-upper, a real old house, and I've been working on it ever since. It's kind of fixed up, but it's 110 years old, so it requires constant maintenance. Rob joined the Stanford faculty a few years after me, and of course Brad Efron was here and is here, and Jerry Friedman, and they were both our teachers back in the 80s, and life was really good. It was really fun. Rob and I worked with Jerry Friedman, and we wrote our book Elements of Statistical Learning in the early 2000s, and we're thrilled at its success. And at Bell Labs, I didn't have graduate students, but now I did. And I've been blessed with 25 PhD graduates, and many of them have achieved great heights and continue to do so. We wrote a book, Introduction to Statistical Learning, with Gareth James and Daniela Witt in 2013, which has been a success. And we're just coming out with that one has... that one's got the subtitle Applications in R, and we've just come out with a new version that's going to be published in the summer with applications in Python, and Jonathan Taylor joined as a co-author. One of the things I really enjoy doing is writing statistical software, and I'm a strong believer in, if you produce a new method, you have to provide software, or it's helpful if you provide software so that people can use your method. Otherwise, it just disappears. I'm very proud of our package GLIMNet, which fits lasso and elastic net regularized linear models, which I wrote with Jerry Friedman, Rob Tipsharani, and our colleague Naris in the statistics department. So my research has always been on the edge of applied statistics and machine learning. And I try and attempt to draw on the commonalities and bridge the gap between these two fields. And I think it's really important, because otherwise machine learning will run away with and AI will run away with our field, and we need to stay in the game. I get my students to engage in real data problems that arise in my medical school work. I have a joint appointment in the medical school. And that often leads to research problems that are relevant. And as I said, I believe in establishing a good balance between work and recreational family life. And so I think I'll stop there, and I hope I didn't talk for too long. Thank you.
Yeah. So thank you, Trevor. So so now I think we can have Susan also join us. So yeah. So now we're gonna have so I'm gonna ask questions, so Susan and then Trevor can answer. So in the meantime, so for audience, if you have questions, you can use the Q&A function for questions. So I will read the question loud. So that if you like, you can also sign your name and affiliation at the end of your question. So we may also have the ability to unmute your mic. So that if you would like to ask a question by yourself, you can also make a note about that. So yeah, so I will start with my own questions. So first question: we all have heroes in our mind. So who are the intellectual heroes or leaders that have had an influence on you? So Trevor or Susan. So
you go first, Trevor.
No, you go first, Susan.
When I think of the people, because I was I had a very different path from Trevor. I was mainly in math, probability, empirical process, but I realized I needed to start thinking about real life problems. And when I thought about who I wanted to aspire to follow, I thought of Brad Efron. I mean, he's just so aspirational. I mean, this is someone who both contributes to our deeper understanding of theory and statistics, but also actually really tackles in a real meaningful way domain science problems. So Efron and then also David Cox. These are the two people who, without a doubt, they're the people I want to follow in their footsteps. That's what I want to do.
That's great. Brad Efron, of course, is on my list, and I've known Brad for a long, long time, since I was a graduate student in 1980. I love Brad. I mean, and he asked me to help him finish a book, computer-age statistical inference, which for me was a great honor. And I wrote 4 chapters, but Brad wrote the rest. And I feel I can brag about that book because it's mostly Brad, and that was for me a wonderful experience. But other of my heroes are John Chambers was a big influence on me while I was at Bell Labs. You know, he was the primary author of the S language, which is used in the R computing environment today, and very smart man, and I learned a lot from him. And then, of course, Jerry Friedman and Leo Breiman had a huge impact on my career. They're both extremely creative thinkers and are responsible for a lot of the important techniques we use today. And then finally, of course, one of my big heroes is Rob Tibshirani. I mean, he's definitely one of the leaders he's one of the top statisticians in our field. And I've had the honor of working with him. And I think we made a good team. Rob is a great ideas person, thinks out of the box, and for me, it has been such a fun ride.
Trevor, did you get Brad to sign the book? You should get him to sign the book you wrote with him.
Oh, he did. I have.
Oh, you're so lucky. So lucky.
I have, definitely.
So lucky.
Yeah, so thank you for sharing the heroes in your mind. So then we come to I have a second question. So what are you personally doing to ensure you continue to grow and develop as leader in statistical research? Yeah.
It's your turn, Trevor, to go first.
Well, I wrote some notes here. Stay fit and alive is one of the things. But I'm not sure about the develop as a leader bit, since I feel I'm on the slippery downward slope as I approach 70. But still may have some wisdom to impart.
It's there's a competition between getting better and a general collapse of the entire system. They're competing constantly. That's how I feel. So what I do is I already said that. I don't have the background Trevor has. I don't have a background in CS at all. And yet now my entire lab's in CS, and it's stressful, but it's very good for me. I learn a great deal.
Yeah. So thank you for sharing that. And then also I mentioned I reached out to Ji Zhu, Professor Ji Zhu from University of Michigan. So he is a colleague of Susan. Also, he's a student of Trevor. So he's sending me a question. So looking back, is there anything you wish you had done differently in your career?
Not me. I don't know about you, Trevor. I mean, at the time, I thought I made a lot of bad decisions, but in the end, I did okay. I've done okay.
Yeah, I don't really have any regrets or things I would have done differently. There's a few papers that I never finished that I wish I had, and it's always gnawed at me. And if you leave them for too long, the moment passes.
Yeah.
But beyond that, I feel like I did pretty much what I wanted to do.
Yeah, actually, now that you're making me think, I think maybe I had a paper or two that I published that I wish I hadn't have published.
Yeah.
Like, for example, it was a great solution to the Rome problem.
Yeah.
Mm. Yeah.
Zhizhu was a great student, by the way. He's, yeah, and I'm so pleased that he's done so well.
Yeah. Yeah, and also like the so looking back, so the what do you think are the most important decisions or choices you have made in your career?
Do you want to go, Trevor? Or do you want me to go?
I'm looking. I'm going through the previous. Oh yeah. Well, for me, I think I was a math. Actually, like I started off as a math wonk, right? I was really into math, but I realized early on that that I needed to find a good outlet for math, and so statistics was a good outlet for math, where you could apply math and solve real important problems, right? So that was a career decision I made, not to carry on down the math track, but to go into an applied field like statistics.
For me, it was, and it was sort of an accidental decision, was I went to Chapel Hill, UNC, and at that time, there was very little statistics. It was all mainly stochastic processes and probability. And that turned out to be a really good decision because it gave me the time to build my math, because I really did come with, I loved math, but I didn't have the skill set. And it gave me the time and space to build the skill set so that I could be more principled when I went on to apply problems later on. So going to UNC was a big deal. It made a really big difference, and it was accidental.
Yeah. So so since we have a lot of questions from the audience, so I start do the Q&A. So I may first go to a question. So so it's about the so from Kai Sun. So now also this is related to a question. So asked by the Hui Zhou, who is my advisor. So would you do it different in the ChatGPT age? So which is currently very, very popular. So and also the question asked by Hui is like, do you see any warning signs for our profession amid the AI revolution?
Do you want to say something first, or do you want me to go?
I can say something. Of course, there are always warning signs, but they've been around since the beginning, when neural networks first emerged in the late 1980s, and support vector machines in the mid 1990s. And as a profession and as a field, we rose to the challenges then, and I think statistics kind of moved and adapted to these new areas and the challenges of machine learning and AI. And of course, now we all, in awe of ChatGPT and GPT-4 right now, and trying to understand what it can do. But I think, there's always going to be a room for statistics and clear statistical thinking, especially since a lot of these models work on massive amounts of data, but the understanding of the models and the predictions they produce become really difficult. So I think the role of statisticians is going to remain strong in these fields, in interfacing with these fields.
I agree. I actually think these fields really need us. And what they're doing now is, so I spend almost all my time now reading in CS, spending time in CS, and many of these papers are citing our work in statistics. So they're borrowing ideas from us continuously, but nonetheless, like, for example, ChatGPT, it uses reinforcement learning. This is an area that's ripe for ideas. Our field, we're the ones, we were in sequential experimentation. It's ripe for our ideas from this is a causal inference area, It's an area in which you really need to understand the statistical properties better. And of course, a lot of computer scientists are starting to borrow and take ideas from us in order to achieve those goals, but they really need us. I feel that these fields really need us badly, and we need to step up to the plate because otherwise the fields are going to go in certain directions. For example, people won't think, well, how do you analyze this data after you've collected it using some sort of reinforcement learning algorithm? They won't think carefully about that, or they may think less carefully just because their utility function doesn't include high quality statistical inference as part of it. And we're really needed in these fields.
Yeah. So thank you. So thank you both. So next, so we're gonna have the question from the Professor Deepak. So this is about so he's teaching like the statistical inference at the PhD level. So every year, so he would like to include some materials on machine learning in the statistical inference class. So, but always found difficulties on what topics to exclude. Do you have any suggestions?
And what topics to include?
To exclude.
I think he should look at Trevor's book.
Well, so, yeah, good idea, Susan.
Thank you.
I think if you want to be credible, you've got to include methods like boosting and random forests, and you've got to include deep learning. Right? I mean, neural networks and deep learning methods have had a huge resurgence, obviously relevant today, and so you need to teach that stuff.
How about sequence modeling? Do you think, Trevor, I mean, that's kind of the latest.
That's the latest, and it's harder, but yeah, you got to have it.
Maybe just an intro to sequence modeling.
Yeah. We wrote in our second edition of Introduction to Statistical Learning, we have a chapter on deep learning, and there's a section on recurrent neural networks for modeling sequences. And by the time the book was published, it's almost redundant because they don't use recurrent neural networks much anymore. They use these GPTs and transformer models and whatever. And but that's because the field's changing so fast. But I think, yeah, got to teach that stuff.
Yeah. So thank you. So the Professor Deepak, if you have any follow-up questions, you can type them on the Q&A. So that we'll continue. So so next question is about the future of statistics. So it's from the Shakil Amit. So can data science replace statistics in the future? How do you see the future of statistics apart from data science?
I don't know. I think they're the same. I always thought they were the same, but maybe I'm confused. To me, data science is statistics, and statistics is data. We're the foundation of data science. I don't know. What do you think, Trevor?
I mean, the word data, I see data science as really just a rebranding of applied statistics, right? Yeah. And a lot of the, what we did, we got better tools today. So we, the things we do in data science have expanded, but it's really what we've been doing in applied statistics all along, Yeah. So, and it's a very important part of statistics from my point of view. I mean, for me, when I train my students, I always get them involved in real applied consulting problems in the medical school and so on with real data, and get their hands dirty. And that's applied statistics, dealing with messy data, before you even get to start fitting models. And that's what's at the heart of data science.
Yeah, so thank you for sharing your thoughts. So so next question gonna be like would you mind sharing what would you think so that would be the next important or pressing issues for young researchers they should be work on? So or I phrase another way, so if you are still in your early career right now in this age, in current years. So what would you work? Yeah. So what topics or what would you choose to work? Yeah.
Susan, your turn.
Oh, I know I would work on reinforcement learning.
Yeah.
That area is so ripe for statisticians, it's unreal. I mean, I think it's, and like I said, ChatGPT is using reinforcement learning. You know, this is all, it's like we developed the foundations of this field, then we walked off. Of course, economics contributed, you know, control theory contributed, but all of these fields, but we developed the bandit, you know, algorithm sequential experimentation. This area is just ripe for statistical innovation in my point of view. And also online, any kind of algorithm that runs online processing data incrementally, I'd like to see a lot more statistical work done for these types of algorithms that process data incrementally and assess their behavior and inferences that can be made. Yeah.
So what do you
I know that those are good suggestions, Susan. You know, one of the things I've been paying attention to and watching, you know, after the initial excitement at how good deep learning models are at making predictions, the field started paying attention to understanding the predictions and, you know, finding out what's important, what's not. And, you know, for any company or industry that uses this technology, that's one of the first questions they ask. And so it's kind of interesting because what happened was that people started looking at these predictive models and trying to come up with simplified versions that explained what was going on. And I was tickled to see that one of the ways they do that is they use generalized additive models. So, you know, which by deep learning standards is considered a very tame model. But when you're trying to understand something and what it's doing, it might give a good approximation. So I think, you know, I think that's important. And also statisticians have a better sense of, you know, when you fit a model to data, I mean, where the data comes from and all the biases and that exist in the data, especially with massive data sets, there's all kinds of biases. Understanding, you know, how that influences the results that you're getting is really important, and to try and tease that apart. It's a very difficult problem, but it's there.
Yeah, and it's ignored a lot by a lot of the other fields. Yeah.
Yeah.
Yeah. So thank you for sharing. I mean, your thoughts. So next question we're going to go to. I mean, for a lot of audience, they are still new researchers or even assistant professors. Do you have any suggestions for them to how to balance they develop their own method, how to do the collaboration with the other fields or surveys and grant proposals? So what recommendation would you get for junior researchers about the time management, about how to balance their efforts?
I don't know. Trevor talked about life-work balance, right? Mm-hmm. I think everybody has their own version of what life-work balance means, and you have to find your own version, one that's acceptable to you and your family. To me, it's more about pursuing something. I mean, the more time I spend pursuing something that makes me excited, the better my life tends to be. I mean, in terms of my work life.
Yeah, I mean, as I said, I really believe in good work-life balance. For example, for the last 20 years, I've never worked past 7 o'clock in the evening. So I'll work hard during the day, but at 7 o'clock it ends. And particularly no screen time, you know, after 7 o'clock. I'm talking about computer screen. And, you know, I think that's important, and it's a good discipline to get into. And what you'll do is you won't put things off. People tend to waste time during the day, and then you put things off and you can carry out, finish it up at night. It's really, that's a bad habit. So if you've got a designated work time, you'll tend to get your things done during that time. The other thing that for me, most of my research has been collaborative. I've had collaborators. As I mentioned, Rob Tibshirani has been a good collaborator. For me, that was very important because that creates some kind of energy that keeps you going and gets, especially with Rob Tibshirani, he's like, really wants to get things done right fast. That would hasten a project along. And then something else that has been special to me is occasionally have a problem that you really love working on and savor it. Don't rush it. Spend time thinking about it. I've had, I've had about 3 or 4 projects like that, and where you can really enjoy it. And the race to publication isn't really there. You just, eventually you'll publish it, but you really enjoy it. And that's actually important for the mind, I think. Because often we're in such a hurry to get things finished and published, and we, it can be sloppy, but every now and then it's important to savor something that you're working on and really enjoy it.
Yeah. So thank you for sharing that. I mean, and also we're gonna go to the next question. So so what is from Leila? So what is your first contribution? So that has been most meaningful to you, or in another, I will rephrase like what is something you have achieved through your career that you are particularly proud of?
I guess for me it was well, it's more recent because that's all I can remember is recent things. But the fact that this experimental design for involving digital interventions, so autonomous interventions delivery, the fact that this experimental design, this randomized trial design, is being used by people I've never even met. I just all of a sudden I see a paper and they're using that design. That makes me feel really good. I did some, I had an impact. I helped, and a lot of times knowing that there's a lot of young scientists in other fields and they're taking advantage of something I made possible, that means a lot to me.
I think for me, it was, I wrote a paper with Rob Tibshirani and Jerry Friedman on the statistical interpretation of boosting. Mm-hmm. Boosting was, this computer sciencey technique. And for me, first of all, we loved working on that because we'd have these long meetings and, and I'd sit at the student union and with my notebook and figure things out. And it took a while. But it was very satisfying, and especially because we think we felt we nailed it, and it did something to blend the two fields together, statistics and machine learning. So that was very satisfying.
Yeah. So thank you. So we have another question. So this comes from the Stella Jia. So so do you have any book recommendations? So that could be related to stats, life, or etc. So that have made a big influence on your life. So I think the audience is curious about the book. Any book recommendations? Yeah.
I like Trevor's book. Statistical machine learning. I really like that book. And I like Cox and Hinckley, which no one looks at.
Oh, I love Cox and Hinckley.
I love Cox and Hinckley.
Yeah. It's a little different from other books, right?
Oh yeah, there's no math. It's all ideas and ways of thinking. It's very hard to study. But it's great.
Well, yeah. So, I'm an avid reader, so not just, recreational reading. And there's 2 books I've read recently. One is The Immune. It's about the immune system. And I've worked in biostatistics and, medical problems for my whole life, but the immune system's always been this kind of mystery. And that book, I'm about to read it a second time because it just blew my mind. And not only is it really interesting, it's well written, but it, you learn how, I already knew how beautifully complex the human, life is. And when you read this book, you realize it's even a whole nother level more beautiful. So that's one. And the other book I'm recently read is called An Immense World. And I really recommend that. It's about the senses. So, we have, as humans, we have 5 senses, but animals have other senses that we don't have, and so on. And that's a wonderful book as well. So these aren't anything to do with statistics, but I strongly recommend them. The Immune and An Immense World.
Yeah, so thank you so much. So let's thank the 2 wonderful speakers again. So through this hour, we have learned a lot about your stories, about your experiences. Also, we are grateful for your advice. So also, we'd like to thank all the audience so much for listening. So that if you found this conversation to be helpful, please share the share the recording with your colleagues. Also, the special thanks to the Amita and Jim, so they're from the COPSS-NISS. And also, we're going to have another COPSS-NISS leadership in the April. So we're going to talk about the leadership in government. So we have another two wonderful speakers, including the Dr. Rob Santos from the census, so who is the director of census. So I think that's all for today. So thank you all. So wish you have a good lunch in the East Coast, or like good morning break in the West Coast. Yeah, thank you.
Thank you.
Thank you very much, Lingzhou.